Okay, so let's finish this up. So far, we've developed a weaving script which can take a surface, divide it up into lines, sort of adjust these lines so they sort of weave by some predefined pattern that we can adjust, and make sort of these fibers that are not intersecting and sort of follow that pattern to weave together into a more complex fabric. So we're using our data management techniques to be able to do this. So the one thing we have left to do, or I guess a couple things we have left to do, is maybe we can map our first script that turns each one of these fibers into a sort of cable or twisted yarn, to add a little more detail to this, and then also sort of map it to a more complex surface. So let's hide that for a second. I lost my viewport. Okay, so we have this. What we essentially have is the curves that we're building this from. So let's look at one of those individually. So we have this set. So we can do the same things that we were doing up here, where we sort of build these circles, divide them, and pipe them. But we need to do it in a slightly different way because we were building it from an XZ plane along a straight line before, but this is now an undulating line, so it's going to work a little different. So instead, let's make we go up to here in the curve tab and perpendicular frames, we can make perpendicular frames along this. We'll give them a little more, say 30 of them. You can see that instead of being along a straight line, they actually undulate sort of perpendicular, or like the Z of the plane is now tangent to that, which works pretty well for what we're doing. Then we can build circles along these frames, and I'm going to make them the same as our was before. 1, 4, 5. I can even loft them to show that they are in fact similar. Okay, our curves, like we had before, are not twisting, so we still need to build that into it. So we can come back here to our frames. Let's rotate these, rotate the plane, just like we did in the first script. We can get the list length for how many frames we have, and a series to then rotate them sequentially. Sorry. So that's the number of times we want to rotate, and then I can turn that into the plane. I can even put a number of degrees that I want to rotate, but I need to change this from radians to degrees up here. So then you can see that these are rotating incrementally across that. I plug them into our circles. You see it's still building the circle, and you can even see where the seam of that surface either coils up or uncoils depending on how much we want to rotate it. Okay. So the last thing we have left for these is to divide it up, divide the curve, make the lines. And just like before, these lines are making the circles because we need to change our data management, and we can use the same sort of path mapper up here because we know that pattern is what we need to work. It turns orange. Why does it turn orange? Well, our data over here is actually not in the same sort of organization that it was before. As you remember, this was A, B, but if we simplify this, it actually goes back to an AB sort of branch structure. So that then generates the twisted fibers that we're looking for. We can hide all this other stuff. And pipe this geometry. It's huge again, so I can make this something smaller, 0.15 seems to work. And then you also notice that the center is empty and these are more like straws, so they're not solid on the end. The E will actually give you the option of how you want to cap that. Right now there's no cap. You can do it flat or round. Just do it round. So that puts little spheres on the end of these. But then the centers are still sort of open. So one thing we can do is create a boundary surface. And these circles are on the end. We can make a boundary surface from them, but remember there's 30 of these that are stepping across that. So we just want the first and the last one. So we can say list item. List item will get us the ones on this end, but if we want the ones on this end, if these are the first, we want the last. We zoom into this and say -1. -1 is the last item on the list, so we can use that one pretty easily. Generate these surfaces. And what we're going to do is just fill that with a lot of random spheres that make it look like that is solid. So we can populate that geometry. Well, now there's 100 points, which is way too many. We're probably more like 10 or 15. See if 15 works out for us. So we can make spheres. And we want to use something similar to the same size radius that we had before. So that one's going to be way too big. Use that, it'll make it a lot smaller. And hopefully it'll look more like there's a bunch of cables that sort of end at the same point. Close enough. So what I can do here is just put all these together. And I have these Twizzler-like fibers that are sort of woven in and out of this mesh. Now I need to do this again for each direction in that woven mesh. But I don't want to just copy all of these things over and down. One, that'll make it difficult to read, but then it's also a lot of stuff to copy. So one thing we can do is make this a cluster. So if you go up to parameters, under utilities, you have cluster inputs and cluster outputs. I'm going to set a cluster output of this data set. And then I'm going to say the angle of rotation to also be an input. So I'm going to slide this over here so I can select all the rest of the stuff. And instead of grouping them together, I'm going to say cluster. And so what that will do is actually make a single component out of all the components I had. If I scroll over it, you can see sort of a shadow of what those components are, and if I double click in that, I can edit this one and then right click on this box over here, or left click on this box and say save, and it'll shoot me back out. Now anytime I copy this, it will be the same component. So if I go in and change something, then it'll change them all. So I'm going to need that, and I can copy this. I'm going to use this instead as my data that I'm plugging in. No longer need that. That's going to be my first data set. Copy this again. And this is going to really start to slow down the computer because we're making a whole bunch of geometry. It's doing a whole lot. But we can get some good, maybe images of this fabric once we bake some of this out. So then these two. Just copying and pasting these down. You can see each time this runs, it's adding a little bit more in terms of time. Okay. So all of our geometry is here. We have a nice looking surface. I'm going to bake that out. Change over to rendered view. And you should see something that looks like a cable mesh. It has the pattern we've sort of selected, and we can clean that up as much as we want to make sure things aren't intersecting, or that spaces and gaps aren't there, or these endpoints look more correct. I'm going to hide that real quick. Turn this back on. The one thing that we haven't looked at is then applying this to a more complex surface. So I've made a more complex surface over here. You see that sort of undulates around. Let's plug this in and see what it does. I'm not sure if I could go through and rebuild all of this again, but it should map pretty seamlessly to this surface as well. Okay. So you can see that that sort of drapey fabric is now sort of mapped pretty well, and all the rotation vectors sort of look like they're supposed to. No problem, it's not sort of messing up from this other geometry. Now this geometry, if you want to see how that was made, I hide this. I just took this base plane and baked it out, and then we're going to rebuild it with a U and V degree of 3 and point counts of 5. Now that allows me to turn the points on, sort of bulldozer on, make a new surface, and then bring it into Grasshopper just the same. So that's about it. Hopefully you can run through this tutorial and understand a little bit about the data sets, how to sort of create your own sort of weaving pattern that you can then build up incrementally with complexity later. That's it.